Okay, hello and welcome to this NEP on inverse functions. So notes, examples and practice questions. The title is inverse functions, so if you are doing this in a notebook or in a folder, that's your title, and we want that nice and clear. And then we're going to move on to the notes. So the inverse function performs the opposite to the original function. So if an input becomes an output, the inverse turns that back into my input. Now, if a function is f of x, the inverse is f minus 1 of x. Just be really, really careful. It's not the derivative, which is f dash x. So you have to be really, really careful that you're really clear on the fact that we're talking about f minus 1 of x. Now, the inverse is a reflection of f of x in y equals x. So whatever my function is, if my function is like this, then the inverse is a reflection in that, so like that. Now that means the domain for f of x is the range for f minus 1 of x, and vice versa. And that's crucial when we later come to try to calculate the range or the domain. We can just use the opposites for the regular function. Now the blue box, this is actually really, really important today. So this is how you find the inverse. So there's a couple of ways of doing this, but I think the best way is to find the inverse. You write f of x as y. So we know that they are equivalent, y equals or f of x equals. And then what you do is you swap x and y. So all x's become y's and all y's become x. Then make y the subject and replace with this. So that is the key, that y has to be the subject. And what we're actually going to do is we're going to number these tasks and then we're going to do them every time. And that matches what's on the answers for the NEP. So number 1 is we write f of x as y. Number 2, we swap. Number 3, we make y the subject. And number 4, we replace again with f to the minus 1 of x. So we're going to use those 4 things every time. So there's the blue box. Write that down. Make sure it's clear. Make sure there's some colour around it, ideally blue. And then we're going to look at our examples. So example number 1, find the inverse of f of x equals this, where x is bigger than 0. And that's often really important, so we're not going to neglect that little bit at the end. Okay, so the very first thing we're doing is we are going to write f of x as y. So number 1, f of x becomes y. So y equals 2x squared plus 3. Then we are swapping x and y, so this is stage 2. So x equals 2y squared plus 3. And then stage 3 is to make y the subject. So starting with x minus 3, then dividing everything by 2, and then square rooting everything. And because x is bigger than 0, that means we're just dealing with the positive section of this. So what we have is we have y equals x minus 3 over 2. And then our final component is to rewrite that as f minus 1 of x for the inverse. And that is our answer there. So we're just following those steps every time, one by one. Number 2, find the inverse of f of x equals this. X is all real numbers, but not equal to minus 2. And we're going to go through the exact same process again. So number 1, we write y equals 1 minus 3x. And then we swap x equals 1 minus, we put a y there and a y there. Now the reason this is the secure question is because here the subject appears twice. So this is going to be practicing some rearranging. You have to be confident with your algebraic manipulation, rearranging, to proceed on to this stage of the course. So we are making y the subject, stage 3. So first I'm going to multiply that across, and then I'm going to expand, and then I want to get all my y's on the same side and all of my non-y's on the other side. Crucially, I'm factorising out the y from here and here, and then dividing. And then finally, step number 4 is we replace, so f minus 1 of x equals. So just a little bit harder there because that subject appears twice. So that is my answer. Okay, question number 3, f of x equals this, x is bigger than or equal to 0. Part A is find the range of f of x. Now this takes us back to our previous work on functions, where to find the range of f of x, we need to think about the shape of the graph. So I'm going to do this in green. So y equals x squared plus 4 actually looks like this, because it's the x squared function, and that's a transformation. So again, everything's linking together. Now x is bigger than 0, so this is actually not defined over here. Now this is 4, so our range is f of x is bigger than or equal to 4. And we're going to come back to that later on. So that is the range of f of x. Okay, part B, find f minus 1 of x. So I'm going to do that first. Now remember, stage 1, we write y equals x squared plus 4. Stage 2, we swap the x's and the y's. And this allows us to make y the subject. So x minus 4 all square rooted equals y. And then finally number 4, f minus 1. So that is my answer to this section here. Now the final part of this question says stating the domain and the range. Now remember, these become the opposites. So this is the range of f of x. So therefore the domain of f minus 1 of x is x is bigger than or equal to 4, because domain is the inputs, so it's the x values. And our range for f minus 1 of x is this component up here, because the domain of the original function becomes the range of the inverse. So that is the range, and this is the domain. So we are always swapping those over. Okay, summary. You need to work through stages 1 to 4. If you work through those stages 1 to 4, you will always be able to find the inverse. Now, the range of f of x equals the domain of f minus 1 of x, and the domain is the range. And that is the end of our summary. Don't forget the things you've learnt before. If you need to go back and look at the introduction to functions, that will be really helpful. Okay, so once you finish your summary and you've written that down in your books nice and neatly and clearly, we're then going to move on to the practice questions. So the practice questions, I suggest you do them somewhere different to your notes. You want your notes to be kept nice and separate. And if you get stuck, you can come and look at the video. You can go back over your notes or over the video that you've watched already, or get in touch. So, question A, find the inverse of f of x equals this. So we're going to work through stages 1 to 4. So first, we'll write as y, then we swap, then we make y the subject. And then finally, step number 4, we rewrite as the inverse. So that is our answer. Number 2 is h of x equals, and it's a bit trickier because the subject appears twice, and this just tells us about the limitations on the domain. So number 1, we still do the same. Number 2, we swap everywhere. Number 3, we are making y the subject. So remember, we want to get our y's together and our non-y's together. And then we are factorising. So y equals, and then very finally we're going to do stage 4, except in this case it's h to the minus 1x, because we have an h function. So that is my answer. Okay, question B. By completing the square, find the inverse of g of x equals this. X is all real values, and sketch both functions. Okay, so we're going to complete the square first, which is going to enable us to rearrange later on. So x plus 3 all squared, and then it's going to be minus 9 plus 4, so minus 5. Now, you probably learnt how to do completing the square right at the beginning of the course, so if you need to go back and recap that, then please do. So number 1, we have y equals x plus 3 squared minus 5. Number 2, we swap. Number 3, we make y the subject. So I'm just going to swap these over. And this should actually be a plus minus. So we have those two options. And then finally, stage number 4 is g to the minus 1 of x equals. And there is our function. And now what we're asked to do is we're asked to sketch both functions. So over here, I'm going to start with sketching my g of x. Now, this is revising and recapping sketching functions, and this gives us the turning point. So the turning point is minus 3, minus 5. So minus 3 minus 5 is down here. So that function looks like this. Now, it's asking us to sketch both functions. Now, I could sketch this as a function in its own right, or I could sketch it as the inverse of g of x. Now, the inverse means a reflection in the line y equals x. Now, y equals x goes like this. So what we're actually doing is we're sketching a reflection in that line. Now, that means that my second curve is going to go through these points here, and my turning point is going to be slightly different. So my turning point is actually going to be minus 5 minus 3, which is here. And so my function is going to look like this. So that is a reflection in the line y equals x. And that's how I can sketch that function. or I could sketch it as I know how square roots look and it's transformed as well. So that's question B. Okay, C, h of x equals 2x squared minus 3. Find h minus 1 of x, clearly stating the domain. So the domain of the inverse, remember, is the range of f of x. So I'm going to do that first. So quick sketch of my function. This is a happy face with a y-intercept of minus 3. So it looks like that, considering our transformations again. So therefore, if x is all real numbers, if this is minus 3, then that means the range is bigger than or equal to minus 3. Okay, now we're going to find the inverse. So number 1, we write y equals. Number 2, we swap our x's and our y's. Number 3, we make y the subject. So finally, step number 4, h minus 1 of x equals, and the domain is x is bigger than or equal to minus 3, because domain's the inputs. Okay, now this final question is in here just to check whether you're confident with the difference between this and this. Now this is the derivative of h. So if h of x equals 2x squared minus 3, then h dash x, the derivative, is 4x. So that's just helping to consolidate that difference between them, and that is the end of the practice questions. So if you would like more practice questions, maybe on functions, then you can find them at www.stutchfield.com.